Negative 3, 7 is a point on the terminal side of an angle, theta. Find the exact value of each of the 6 trig functions. All right, hold on. This is going to undo. Try that again. Yeah, there we go. Okay. So let's make a little coordinate grid and plot left 3, so here's theta. And what I want to point out is something we did yesterday. Got erased, but I'll do it again. You remember yesterday we looked at, if I did the sine of 30, and we said that was 1/2, and when we came over here, sine of 150 was the same, and if you did all students, sine 150 was also 1/2. And if you did the cosine of 30, we got radical 3 over 2. And then when you went over to cosine 150, what was the only thing that changed in the second quadrant?
Negative.
It was negative, right? So guess what? My angle theta here is going to be the same as the reference angle. So I'm going to drop a perpendicular to the 3. We're going to pretend that's to the 3, okay? And this is left 3, up 7. Go ahead and take a moment and find the hypotenuse using Pythagorean theorem. A squared plus b squared equals c squared. Go ahead and find the hypotenuse. So what are you getting for the hypotenuse? Zach, what'd you get?
58 equals c squared.
Yeah, so that's the square root of 58, right? So the sine of theta is going to be the same as the theta that's inside the triangle, as long as I take care of all students take calculus. So the sine, you're going to use SOH CA TOA. That's 7 over the square root of 58. Cosecant is the reciprocal. Well, I can't leave a square root in the bottom. So I will rationalize it. Thank you. Now let's do cosine theta. Cosine theta, now here's the cool part. If I label that left side -3, that's going to take care of my all students take calculus. So this would be adjacent over the hypotenuse. Secant, I'm going to flip it. Now we always put the negative up in the numerator. Then I'm going to go back up to cosine and rationalize it. It's really, really, really important, though, that you write this initial step. The reason why we want to write this instead of jumping to the simplified answer is when I go to do its reciprocal, it's an easy reciprocal. If I want to flip this one, that's yucky, okay? That's super yucky. I don't want to work with that one when this one puts the radical up in the numerator. If the radical simplifies, then you need to simplify it. 58 is 2 times 29. That doesn't simplify. And if the fraction can reduce, I would reduce the fraction. All right, now let's do tangent. Tangent would be 7 over negative 3. Cotangent would be negative 3 over 7. Now, I'm going to tidy up that tangent. We don't leave a negative in the denominator. We pull it up. So that's the only thing I'm doing there. So let me talk you through this one more time in case I went a little too fast. If it says you have a point that's on the terminal side of an angle, plot the point. Then you're going to create a right triangle to the x-axis. So if I would happen to have a point down here, the triangle is going to go perpendicular to the x-axis. If I have a point in the fourth quadrant, it's going to go perpendicular to the x-axis. Never ever am I drawing it to the y-axis. Then find the hypotenuse by doing a squared plus b squared equals c squared. And then you do SOHCAHTOA. That's it. Okay? All right, let's look at example 4 then. Using the given conditions, find the exact value of each of the remaining trigonometric functions of theta. So cosine theta equals 3 over 7, and sine theta is less than 0. One of the things I absolutely love about math is, to me, I feel like I'm solving puzzles, and I love doing puzzles and riddles and things like that. So I'm going to pause a moment and I'm going to think. And that's what I have realized is students get frustrated because they think they're supposed to look at a problem and just know what to do. That is false, okay? That is false. You are not supposed to just know what to do. But you have to be patient to figure out what to do. And so students get frustrated. They're like, I don't know what to do. So then maybe they feel badly and then they just give up. Well, Algebra 2 is about thinking and processing and analyzing, and that's what's so fun about it. So here's what I'm going to start with. All students take calculus, and I'm going to ask myself, what do I know? If cosine theta is a positive 3 over 7, in what 2 quadrants would you find cosine is positive? Yeah, Melanie?
Is it 1 and 4?
Awesome. That's 1 and 4. Now, sine theta is negative. Uh-oh. Which of these 2 can it be if sine is negative? Okay, but it's got to be out of these 2, 1st and 4. So like that's a given because it says cosine theta is positive. So it's only in the 4th quadrant, right? So now I know I'm in quadrant 4. Does that make sense? Now I know what quadrant I'm in. So here's what we're going to do. We're going to draw a triangle in the 4th quadrant. Cosine from SOHCAHTOA is adjacent over hypotenuse. The adjacent is the 3, the hypotenuse is the 7. Okay, cosine theta is 3 over 7. That's adjacent. Adjacent over hypotenuse. Then use a squared plus b squared equals c squared to find the missing side. So that's 3 squared plus b squared equals 7 squared. B squared is 40, so b is the square root of 40. Uh-oh, square root 40 can be simplified. That's square root 4 times square root 10, so this is 2 square root 10. Now you have 2 options. You can either do all students take calculus to figure out whether things are positive or negative. That's an excellent option. The other option is any sides that go left or down, label those negative, and that takes care of all students take calculus. So I'm going to go with option 2, and I'm going to call that -2 square root 10. It's right, so the 3 is positive. My down is negative. The hypotenuse represents the radius of a circle, so the hypotenuse is never, ever negative. All right, so here we go. Then if I want to find the other trig values, sine theta, SOHCAHTOA, TOA, is -2 square root 10 over 7. Cosecant, oh yuck. This is going to go 7 over 2 square root 10. And there's a negative. I'm going to put the negative up in the top. So I've got to rationalize it. 2 times 10 is 20. All right, does everybody see that? Sine theta is from SOHCAHTOA, opposite over hypotenuse, and it's always from the x-axis, okay, from your theta. I have cosine, so secant is 7 over 3. Tangent is TOA, -2 square root 10 over 3. Excuse me, TOA, opposite over adjacent. Then cotangent, I'm going to put the negative up in the top. Yuck. I've got to rationalize that. So that's -3 square root 10 over 20. Let me go through this one more time in case you were writing and you didn't quite hear what I said. So it says, using the given conditions, find the exact value of each of the remaining trigonometric functions of theta. So there are 6, and they gave me one of them, so I have to find the other 5. Cosine theta is 3 over 7. I know that's first or fourth quadrant, so that's what I'm starting with. And sine is negative. That puts it in the fourth quadrant. So then I drew a triangle where theta is to the x-axis in the fourth quadrant. Cosine is CA, adjacent over hypotenuse. Use Pythagorean theorem. We simplify all radicals. You cannot leave square root 40. That you would lose points. Then I'm going to do SOHCAHTOA. Sine theta is opposite over hypotenuse. Flip it for cosecant. Secant is just 7 over 3. Tangent is TOA, opposite over adjacent. Cotangent, you flip it. Yeah.
Why did you determine that it was either an A or C?
Cosine theta is positive. All students take calculus. So cosine's positive in the first quadrant, and cosine's positive in the fourth quadrant. So the A stands for sine, cosine, tangent. They're all 3 positive. In the fourth quadrant, the C stands for only cosine. Does that make sense?
Yeah.
Okay. So now let's do another one. In example 5, it says, I'm given tangent theta is -5 over 4. All right, so let's play the what do I know game. In what 2 quadrants would tangent be negative? Good job. That's 2 or 4. Now that's my given. That's what I know for sure. I'm in the second or the fourth quadrant. But cosine is positive. Uh-oh. What quadrant is that out of these 2? 4. So I'm going to go in the fourth quadrant. Draw a triangle. Tangent is TOA. That's 5 over 4. And one of these has to be negative. And it depends. So it depends on what quadrant you're in. I'm right, so the 4 is positive, but I'm down, so the 5 is the negative. We talked earlier about 3, 4, 5 right triangles. This is not a 3, 4, 5. Why is the hypotenuse not the 3?
The hypotenuse is the longest side.
Yeah, in a right triangle, the hypotenuse is always the longest side. So it can't be a 3 there. So guess what? We're going to do 4 squared plus negative 5 squared equals c squared. And I do not care if you set it equal to x, okay, instead of a c. Yeah.
Wait, why is the 5 a negative again?
Okay, so do you see there's a negative out front and then 5 over 4? So I have two possibilities. Either the 4 is the negative or the 5 is the negative. In the fourth quadrant, x's go 1, 2, 3, 4, 5, 6, 7, 8, and so on. So to the right is positive. But my y values in the fourth quadrant go negative 1, negative 2, negative 3, negative 4. So the 5 on the vertical had to be negative because it's going down.
Okay.
Does that make sense?
Yeah.
So over here, it's going to be left and down, so it's going to be like negative 3, negative 4. Over here, I go negative 3 and up 4. And here, I go 3 and up 4. You know what I mean? Does that make sense? All right, so let's find that missing side. I'm going to get 16 plus 25 equals c squared. So c is the square root 41. Square root 41 is a prime number, so it does not simplify. On this one, I'm only asked to find sine theta and secant theta. So sine theta is negative 5 over square root 41. If you can rationalize in your head, go for it. If you need to write it out, go for it. Secant is the reciprocal of what trig function? Cosine. So if cosine is adjacent over hypotenuse, this is going to be hypotenuse over adjacent. Oh, guess what's so cool? Cosine is positive in the fourth quadrant. Its reciprocal is positive in the fourth quadrant. All right, the last thing I want to get to today is this big giant circle, okay? We're going to spend the rest of our time doing this. Then we will end up finishing example 6 and 7 tomorrow, and that's fine. We're just going to take our time to get through it. All right, so the first thing I want you to do on your circle is I want you to go around, and we're going to label the quadrantal angles. Your quadrantal angles are 0, 90, 180, 270, and 360. Quadrantal angles are angles who have a terminal side on an axis, the x-axis or the y-axis. All right, over here at 0 degrees and 360, that's the point 1, 0. At 90 was 0, 1, negative 1, 0, and 0, negative 1. Do you remember from yesterday? X comma y is cosine t comma sine t. You're supposed to remember that. If you're sitting there saying, oh, we did that, then you need to make sure you're doing something to get yourself to remember what we learned the day before. It means making flashcards, making your own Quizlet, doing something that helps you to remember. One other thing we did is we said tangent t was sine t over cosine t. That's what we learned yesterday. All right, here's what we're going to do now. We're going to go halfway in the first quadrant. How many degrees is halfway between 0 and 90? 45. Is if I go 45 degrees in from 90, what would be that angle? Oops. What happened? Thank you. See it now? Okay, so if I go 45 in from 90, what is that? 135. And if I go 45 into the third quadrant from 180, how many is that? 225. And if I do into the fourth quadrant from 270 plus 45, 315. So you need to remember these, and you can figure them out, okay? 45, 135, 225, 315. Here's a big idea. Down below the circle, I want you to draw your 45, 45 right triangle. So that was 1, 1, square root 2. What is the sine of 45 degrees based on this little triangle? Square root 2 over 2. And guess what? Cosine 45 is square root 2 over 2. They're the same, right? Because it's 1 over square root 2. So now I'm going to make a connection to what we did yesterday. Every x-coordinate is cosine of the angle of rotation. So cosine 45 is radical 2 over 2, and the sine is radical 2 over 2. So at 45 degrees, there's an x comma y that's square root 2 over 2, comma, square root 2 over 2. And remember, all students take calculus. In the second quadrant, my cosine is negative and my sine is positive. So at 135, that's negative square root 2 over 2, comma, square root 2 over 2. In the third quadrant, cosine and sine are both negative. So at 225 degrees, that's negative square root 2 over 2, comma, negative square root 2 over 2. In the fourth quadrant, cosine is positive and sine is negative. So at 315 degrees, the x-coordinate has a value of positive square root 2 over 2, and the y-coordinate is negative square root 2 over 2. All right, down at the bottom, I want you to draw a 30-60 right triangle. Your 1, 2, square root 3. So the sine of 30 is 1/2, and cosine of 30 is square root 3 over 2. So watch what I'm going to do. I'm going to go through the circle, and I'm going to go 30 degrees away. So if I go 30 degrees away, the cosine is square root 3 over 2, and the sine of 30 is 1/2. In the second quadrant, if I'm 30 degrees away, that's 150. Well, cosine is negative there, so it's negative square root 3 over 2, and sine is positive 1/2. Because it's the same as sine 30 and cosine 30, as long as you take care of all students take calculus. How many degrees would be 30 degrees in from 180? 210. So cosine is negative and sine is negative. Then let's go 30 degrees away from 360. That's 330. Cosine is positive and sine is negative. All right, then my last one I need to do is 60s. So if I put 60 degrees, let me go back to my little triangle. The sine of 60 is square root 3 over 2. Cosine 60 is 1/2. So here's the big idea. Everything is coming from the 30-60 right triangle, the 45-45 right triangle, or the quadrantal values. If you know the two triangles and the quadrantal values, you're golden. All right, so I'm going to go whipping around now. At 60, this is going to be 1/2 comma, square root 3 over 2. This one would be 120. So cosine is negative and sine is positive. So I'm 60 degrees away from 180. Okay, they're the reference angles from the x-axis. So 60 degrees from 180 is 120. And if I go into the third quadrant, that's 240. So that's negative 1/2, negative square root 3 over 2. Here's 300. Cosine is positive and sine is negative. So I tried to go around 60s in green. Hopefully you can see that. This is what students call the unit circle. I'm embarrassed to admit that early in my teaching career, I used to make students memorize this, and I would give them a blank one and give them 4 minutes, and they had to fill the whole thing out. And we did them over and over and over again, and thankfully I learned better than that. But yeah, I used to do, I think back to things I used to do, freak out things I did to students. I'm like, so glad I've gotten better each year. I'm not ever going to ask you to memorize the circle. I'm going to expect you to be able to come up with your values based on the two triangles and the quadrantal values. So tomorrow we're going to do another, and I don't know why I shouldn't even call them speed quizzes because you have as much time as you want, okay? But we're going to do one more that's first quadrant because most of you did just fine. But I had a handful of students that really were not connecting the dots, and I need to return these real quick. I think I have here. So I want to return these. So tonight, good question. So last night you did 1, 2, 3 and the spiral review. Tonight you can do 4, 5, 6, 7, and 8. So you're not really doing that much homework. So 4 through 8 tonight. No, I'll fix that. Okay.
Maybe you shouldn't have got a concussion Can you play? Yeah.
No, until Thursday.
Okay. This is actually not bad.
Yeah, I'm starting my return to play stuff today, but I'm just.
All right, yeah, I'll fix that third worksheet. So tomorrow we'll end up finishing this, and then thing is on Thursday I want to move into 7-4, so I got to figure out what to do with that last one. Okay. All right, have a great day, everybody. Oh, kidding.